Okay, good morning everyone. So welcome to the next problem, which is on kinematics once again. Okay, a ball is suspended from a string of length 7.5 meters. The ball is kicked horizontally and rises to a maximum height of 6 meters. Okay, before we start, I'll tell you that this problem is for 10 marks. So what I've done is I allotted 10 minutes for solving this question. Okay, so you are hitting the football from here, and as a result of it, it rises. How does it rise? It rises like this over here, right? Which means it's describing a circular motion like this, right? And it goes to stop. Now what is this asking? Assuming the air resistance is negligible, show that the initial speed of the ball is 11 meter per second. So what was the initial speed? That's the question over here. So how do you answer this? See, why did the ball go upwards? Because you gave some energy here. What was the energy? Kinetic energy, half mv square, right? And it went upwards. What is the energy at this point? Okay, it says it stopped. It doesn't stop or anything like this. It rises to a maximum height. What do you mean by maximum height? It doesn't go beyond this, right? So therefore, this should be the potential energy at this point should be equal to mgh. So mm goes away. I want to find v square here. So I will now find out v square is equal to 2gh. Seems familiar, right? So 2 into 10 multiplied by, what is the height here? Height here is 6 meters. So this is 6 meters. So which should now be 2 6 are 12. This should be 120. So thus v should be equal to square root of 120. You can use your calculator to find out, or you can say it's closer to 121. So this should be nearly equal to 11 meter per second, because 11 square is 121, right? Okay, let us move on to the next one. The mass of the ball is 0.55 kg, and how much mass is 2 marks? Okay, so first is conservation of energy, second is final velocity. Then mass of the ball is 0.55 kg, and the impact time of the kicker's foot with the ball was 150 millisecond. Is the time, millisecond over here. Estimate the average force exerted by the ball on the ball by the kick. Okay, so whenever there is a impact time given, definitely is asking you the force. How do you find force? Force is equal to m into v minus u divided by t. Okay, now what is m? 0.55, which is given. What is v? V is nothing but we just found out 11. Final velocity. What is u? U means when the ball was not being hit. Okay, the initial velocity, which was 0. It was ball was at rest, divided by time taken. What is the time at which the kicker's foot was in contact with the football? 150 milliseconds. 150 into 10 to the power of minus 6. When you do this, where is my calculator? It's here. So I get this as 0.55 star 11 divided by 150. So it's equal to 0.04 into 10 to the power of minus 6. What is that? I need force here, right? So I can put this as 40 kilonewton. Bapre, this is too much, right? So 40 kilonewton. Did I miss anything? I missed something over here. 0.5 kg, 0.55 kg, and milliseconds. I made a mistake here. 10 power minus 3 here. So this should not be kilonewton. This should be 40 newton over here. This should be 10 power minus 3, 40 newton over here. Okay, next. Explain why the tension in the ball increases when the ball is kicked. Okay, what happens over here? So as you see here, the tension in the ball at this point is only so much. There's no tension at all. It's not been hung like this, right? It's suspended. Okay, it's tension over here. When you hit it over here, let us say at this point, for example. So at this point, if I consider, it is nothing but tension is equal to mg. If I draw the free body diagram, when it is at this point, the ball anyways hung here like this, right? Otherwise, it will not go in a curve like this. It could go in anyway. Okay, so therefore here what happens is, this is your tension over here, this is your mg over here, this will be your, let us say this is your theta, this will be your mg cos theta over here, and since it's moving in a circular motion, you can write the equation as a t minus mg cos theta is equal to mv square by r, right? R anyway is larger, but v is very very high, you get v square. So thus you see t is equal to mg cos theta plus mv square by r. At any point of time, this is what is happening, which means the centripetal acceleration is now getting added to the tension, right? So tension will definitely increase. Now I explain why the tension this thing increases immediately after the ball is kicked. Reason is because, 3 marks over here, when the ball is kicked, what should you do? You should say it undergoes centripetal, it's a circular motion. This is the first point. And second point, what does it say? When it undergoes centripetal motion or circular motion, what happens? Centripetal force acts on the ball along the string. along the string, right? And what's the third one? Third one is that this adds up to the existing tension in this string. That's it. Okay, you got all the 3 marks. Then calculate the tension to the string immediately after the ball is kicked. Assume that the string is vertical. So which means what? You are having tension like this over here. mg is like this over here, and then you are hitting it here like this. So mv square by r will be acting like this over here. So apply your free body diagram. So this is your mg here, and thus you have T minus mg is equal to mv square by r. T should be equal to mv square by r plus mg. Okay, I did not use a cos theta because it says calculate tension the string immediately after the ball is kicked. Okay, at this point only. It has not made an angle now. It is just about to make an angle. Okay, assume the string is vertical. That's what it tells you. So which should be, I take m common. What is v? We calculated the value of v. What's the value of v? We calculated the value 11, right? So therefore 11 square divided by, what was the radius of the string, radius of the ball, this one path, this was 7.5 meters. 7.5 meters, 7.5 plus 10 over here. When I do all this, and what is the mass of this? 0.55 kg. 0.55 kg. Oh my god, this is what I minimum I have. Okay, so let me use my calculator to find what is this now. This should be 121 divided by 7.5. I get this 16.13 plus 10. I get this as 26.13. So this answer should be 26.13. The dot here. Okay, this multiplied by 0.55 will give me 14.37. 14.37. What is this now found out? The tension over here. Anything I have missed over here? Nothing I have missed. Which should be around 14.4 Newton. Okay. Or if you want to put it only in two significant figures, you can just put it as 14 Newton. According to the marking scheme, it is being put as 14 Newton. So thus we complete all the problems. Okay, as of today. So let me see how you guys are going to work on it. How do you get the answers properly? And if you do not get anything properly, do ask me, or maybe you can put it in the comments in YouTube, so that I'll be able to happy to answer all your doubts. Okay, if I had been a bit faster, then that could be one way of learning things in a more amicable way. Thank you for being with it. Ultimately and finally, the word which every YouTuber says is that do subscribe to my channel and follow all the updates. Thank you.